Hi, welcome to my video on evaluating trig expressions with special rotations. Let's do some examples, and if you wish you can pause the video before I start and work out the question and see if your answer is right. Do that for each question. Find the exact value of each. Number 1, the cos or cosine of 30 divided by the sine of 45. Well, let's draw two triangles, let's draw two sets of circles, and one for the rotation of 30. So this is the rotation of 30, moving up here, and this is the point 1, 0. So rotate 30 degrees. We draw a terminal arm going out through, perpendicular to the x-axis. The arc is 30, so the central angle is 30, so we got a 30, 60, 90 right triangle. The hypotenuse, or the radius of the circle, is 1. This side right here is opposite 30 is a half, and the side opposite 60 is root 3 over 2. And we have the cosine of 30. Cosine is the x on the unit circle, and so the x is root 3 over 2. And the sine of 45, let's draw another circle, and we have 1, 0, and we're rotating 45 degrees right to there, and we draw a terminal arm going to the end point where that rotation stops, and drop a perpendicular to the x-axis. Again, this reference angle, this arc is 45, so this reference angle is 45, so this is the 45, 45 right triangle. Again, the radius of the circle is 1, or the hypotenuse is 1. So this side is the y, so it's root 2 over 2. This side is the x, so it's root 2 over 2. And so the sine of 45 is the y, which is root 2 over 2. And we simplify, so that is root 3 over 2 multiplied by 2 over root 2. And the 2's cancel, so we get root 3 over root 2. And we rationalize denominator by multiplying both numerator and denominator by root 2. So root 3 times root 2 is root 6. And root 2 times root 2 is root 4, which is 2. Or we can call it 1/2 root 6. And number 2, 8 cos 120 minus 3 tan of a negative 135. Let's draw the circle with 120 degree rotation. So this is the circle. And we're rotating on a unit circle. 1, 0, rotate 120 degrees, 90, and that's 120. And we draw a terminal arm. That means that that's 120, 180, halfway around, so this is a 60. So the central angle is 60, perpendicular to the x-axis. The triangle is 60, 90, and 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. And the y is positive, and the x is negative. So the cos of 120, cos is the x over the r, or just the x, which is a negative a half. Now we have to work out the tan of a negative 135. Again, let's draw another circle, and we'll rotate again on a unit circle. A negative 135 is 90 and right to here. So that's a negative 135. Terminal arm moves out. So that's a negative 135. This arc right here is 45. So the central angle is 45, perpendicular to the x-axis. The triangle is a 45, 45. So this side is root 2 over 2. And this side is root 2 over 2. And the x is negative, and the y is negative. So the tan of a negative 135, the tan is the y over the x, so it's a negative root 2 over 2 divided by negative root 2 over 2. And we simplify inside the brackets first. So let's just leave this negative a half alone. Multiply by 8. And there, when you divide the same number by itself, you get 1 except for 0. So negative root 2 over 2 divided by negative root 2 over 2 is 1. So we simplify by PEMDAS. We do the inside the brackets first. And now we multiply these two. So that's 2 into 8 goes 4. So that's a negative 4 minus negative 3 times 1 is negative 3. So we get a negative 7. So we're using the special rotations. Find the exact value of, and so we have the sine of 120. So let's go down here and keep it open. Let's draw the circles down here. So we have the circle is 1, 0. And so right here is 0, 1. And right here is negative 1, 0. And this one is 0, negative 1. So a positive 270. Positive 270 is right around right to here. And so sine is the y, so that's negative 1. Now we have to work out the secant of 315. Okay, here we go. But we're doing the secant of 315, and the secant is 1 over the sine of 315. So let's draw the circle. Again, unit circle 1, 0. So we rotate around 315 degrees, right around, right to here. So that's 315 degree rotation. This is a 45, makes the 360 all the way around. 360, 315, 45 is 360. Draw a terminal arm out to where the rotation ends. And this central angle is 45, perpendicular to the x-axis. This angle is 45, so this is a root 2 over 2. And this y going down here is root 2 over 2. But the x is positive in quadrant 4, and y is negative going down in quadrant 4. So we need the cos is the x, so the x is root 2 over 2. So that gives us 1 times 2 over root 2, which is 2 root over root 2. And we rationalize by multiplying by root 2. So 2 times root 2 is 2 root 2. Root 2 times root 2 is root 4, which is 2. The 2's cancel, and I get a root 2. So this becomes a root 2. Notice I did all the work down here, and I don't have to simplify this expression. Means you don't have to keep writing down the problem. Now we got 2 root 6, and we're multiplying it by the cosecant of 120. So let's draw 120, a circle with 120 degree rotation. So this is, again, the unit circle. 120 is right to there. And terminal arm goes out through. So 120 and 60. So that's a 60 there, and 120 makes 180, perpendicular to the x-axis. So the measure of the arc is equal to the central angle 60. So this angle is 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. And this is the y going up. So the y is positive, and the x is negative. And we want the cosecant. So the cosecant of 120 is 1 over the sine of 120. And the sine is the y, and the y is root 3 over 2. And that gives us reciprocal is, I could go 1 times the reciprocal like that. And that gives us 2 over root 3. times root 3 over root 3. So that gives us 2 times root 3 is 2 root 3. Root 3 times root 3 is root 9, which is 3, or any square root multiplied by itself gives you the same number. So that's 2 root 3 over 3. Again, I fully simplified it. So let's multiply. We have all simplified inside the brackets, so we'll multiply these two and then these two. Negative 1 times root 2 is a negative root 2. And add on. 2 times 2 is 4. Root 6 times root 3 is root 18. All over 3, that's over 1, so that's a 3. And we have to simplify the root of 18. And root of 18 is the root of 9 times 2, so that's 3 root 2. So that's 4, 3 root 2 over 2. Negative root 2, and the 2 cancels into 4, 2, so that gives us 6 root 2. And a negative 1 plus 6 root 2 is 5 root 2, fully simplified. Again, I worked them all out and had less. So working each of these out like here makes the working of this problem easier. And I always draw the diagram. Just makes it easier to do. And the last one to do, find exact value. Number 4, we have an angle of 240 degrees. So let's draw the rotation of 240. And again, the unit circle, 240 degrees, 90, 180, and right there. So that's 240 degree rotation. Draw a terminal arm out through, perpendicular to the x-axis. So that's 240. Then that's 180 as far as here. So 180 plus 60 makes 240. That means the central angle is 60. That means that this angle is 30. Opposite 30 is a half. Opposite to 60 is root 3 over 2. And the x is negative in the third quadrant. The y is negative in the third quadrant. So the sine of 240, sine is the y. So it's a negative root 3 over 2 being squared. Notice the square here. And now we have to do the cot of the 45. Okay, let's draw a rotation of circle with 45. Again, the unit circle. 45 is right here. Terminal arm out through, perpendicular to the x-axis. The arc is 45, so the central angle, the reference angle is 45. This angle is 45. And because it's a 45, it's a negative. Oh, I'm doing a positive. So it's the same thing, only I wasn't watching what I was doing. It's the same diagram, only it's on the, this is the positive rotation. I have a negative 45, so I had to go this way. So that's a perpendicular, that's a 45. So this side right here, I just draw a little arrow. This side right here is root 2 over 2. And this side right here is negative root 2 over 2. And we got the cot. So the cot of negative 45. Cot is the x. Tan is the y over the x. Cot is the x over the y. So the x is positive root 2 over 2 divided by the y, which is negative root 2 over 2. And they're the same, so we divide positive by negative is a negative 1. So the cot of a negative 45 is negative 1. And we have 180. Again, without drawing, let's use this circle. That's 1, 0. This point right here is 0, 1. This point right here, when you rotate, that's the 90. This is 180 here. This is a negative 1, 0. And 180, cos is the x, and so the x is a negative 1. So that's negative 1. And now we have to work out the secant of 60. And let's do the rotation, 60. And 1, 0, 60 degrees, right to there. Terminal arm out through, 60-degree rotation. And we drop a perpendicular to the x-axis. Reference angle is 60, same size as the arc. This angle is 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. And let's see, the secant of 60 is 1 over the cos of 60. The cos is 1 over x, so that's x is a half. So 1 divided by a half is 1 times 2 over 1, which is 2. So the secant of 60 is 2. And we have all the brackets worked out, so we have to do the power, PEMDAS. P-E-M-D-A-S. We got the brackets done, but we have to do the powers next. So negative times negative is a positive. Root 3 times root 3 is 3. 2 times 2 is 4. So we have that. And I'll just work on that power only. Now I have to do the multiplication division, PEMDAS. I got multiplication and a subtraction, so I multiply. I get a negative 3 over 4. Negative, and that's a negative 2. So I'm multiplying. I'm leaving the subtraction to last. So I multiply these two, and I multiply these two, and I left my subtraction to last. Because I'm subtracting, double negative makes a positive. So the 2 is over 1, so negative 3/4. And we multiply by 4 over 4. That gives us 1 times 4 is 4, 2 times 4 is 8. We need a common denominator. And negative 3 and 8 is 5 over 4, or we can go 1 and 1/4. And again, I've worked each of these out individually. Makes it much easier when we go to evaluate them up here. And that's using the trig ratios of special rotations, special reference angles, very important in trig. And if you like my video, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel, Math Fully Explained. Thank you very much. Bye-bye.